In this video, we're going to learn a new inference rule called universal instantiation. It's the new rule for our universal quantifier. So basically what it says is if you have a universal quantification, then you can take the initial quantifier off, and you can take off the variable, and then you get to replace that same variable or whatever else it occurs with any term you want. So any little a, little b, little c, little I, little j, little o, little x, little y, little z, any of the little letters, any term whatsoever, and we abbreviate that with UI. So let's look just at some English examples of UI to make sure that we think that, yeah, this is a good rule, that it's a valid or sound rule. So suppose we take the sentence everything is such that it is tall, and supposing it's true, consider what would follow from that. Well, whoever Bob is, he's tall, and whoever Roberta is, she's tall, and in general, whatever we might point out with that, it's tall, because what our sentence says that everything is such that it's tall. So whatever we're using that to talk about, it's tall too. Now, is it true that everything is tall? No, but if it were true, all of those would be true as well. Or if we had a more complex universal statement like everything is such that, if it is a whale, then it is a mammal, then we could conclude, for example, that if Bob is a whale, then Bob is a mammal, whoever Bob might be. And we could write many such sentences if we wanted to, and they would all follow from that everything statement, putting in different names or pronouns. And we could say everything is tall, and the same thing would follow. Everything that is a whale is also a mammal. That would follow. Or even every whale is a mammal. That would imply that if Bob is a whale, then Bob is a mammal. So hopefully the English versions of UI seem to you like they're valid. And UI is as well. Let's make sure we understand how the rule works. So if we have for all x fx, what do? We take off, and we want to apply UI. Well, we take off the initial quantifier, and then we take off the variable that's attached to that quantifier, and we're left with that formula fx. And what do? Well, we choose a term, any term we want. It could be x, but it could be any others, and we replace all the x's with that term. So there's just one x in fx, so we get to replace that with any term we want, with a or I, or just replace the x with x, so we get out what we started with, or the z. So the a can be any term there, and we could do all of those in the same derivation, right? If that universal statement is true, then all of those are true, so we can say all of them. And that makes UI unlike our previous rules. We can get, with most in general, let's say, well, so with simplification, you get two things out of it, right? You get the left conjunct and the right conjunct. Well, this, you get as many things as you want out of it. In a way, a universal statement is like an infinitely long conjunction. It's this is F, and that's F, and that's F, and that's F, and that's F, and everything. So you get to say each one of them if you want to. So that's our UI rule. Now, let's say we had a bigger statement, like for all x, fx, or gx. We do the same thing. We take off the universal, we take off the x, we choose the new term we want, and then we go through and we find all of the x's and replace each of them with our terms. So we replace both the x's with a and get fa or ga. F is a frog, or sorry, Alfred is a frog, or Alfred is a giraffe. Igor is a frog, or Igor is a giraffe. Xavier is a frog, or Xavier is a giraffe. Zelda is a frog, or Zelda is a giraffe. Each of the x's, when we do the replacement, we replace it by the same thing. All by a's, all by i's, all by x's, giving us back what we started with, without the universal quantifier, all by z's, whatever. We could do all of those if we wanted to, and more, one for each of our different terms. One thing that we'll see with universal instantiation is that you have to decide which one do I want, or which ones do I want sometimes. Just point out two applications that are not legitimate. Of course, if you're using command mode, the program will never let you do those, but you might want to understand why it won't let you do those. So let's say we had for all x, fy. Well, our rule says you take off the universal quantifier, you take off that variable, but then you only get to replace that variable. So in this case, because it's for all x, we only get to replace occurrences of x. And there aren't any occurrences of x in that the rest of that formula. It's fy, and so we can't replace that y with anything. We can't change the y. If we apply universal instantiation to for all x, fy, the only thing we would get is fy. The other thing is when we do the replacement, we have to replace all of the x's, or whatever variable it is, by the same term. So in this case, it looks like, oh, that the x in fx was replaced with an a, and the x in gx was replaced with a b, so we replace the x's with different things. You can't do that. You have to replace them uniformly. So you pick whichever term you want to be the new term, A or B or I or Z or X or whatever, and then all of the X's had to be replaced by that one new term. And so both of those are not illegitimate, are not legitimate applications of UI. So our strategy has 4 steps. We set up the derivation as usual. If you're trying to show a conditional, or you definitely want to make a conditional assumption. If you're trying to show a negation, you do assume ID. Sometimes in some of the derivations, you won't need to do anything and you'll complete it. You won't need any assumption and you'll complete it as a direct derivation. But the indirect assumption will never hurt, and you always want to make a conditional assumption when you can, preferring that to an indirect assumption, of course. And then any immediate subderivations you might do would be fine as well. And then you go ahead and apply your inference rules. And so you would use UI as well, and probably you'll want to do UI as soon as you can. Introduction rules, if they help. If the derivation gets stuck, you would do a subderivation as usual. In particular, if there are no fruitful rule applications, you do something that will help you box and cancel, and then you finish up by boxing and canceling. So in the next video, I will do some example derivations, and there's some strategy to actually applying UI, and I'll discuss that as well. To wrap up this video, we'll just look at a couple rule recognition problems. So we have for all x, if fx, then gy, and the conclusion is if fx, then gy. So is there a rule that applies there? So in particular, does ui apply there? We might wonder because we have an x and a y in there, and so we have different variables in our conclusion. Is that okay? And the answer is yes. This, in fact, is an application of UI. Why is that? So the way UI works is it says when you have a universal quantification, you apply UI. How do you do that? You take off the universal quantifier, you take off that variable, and then you look for all the occurrences of that variable and then replace them with whatever you want. So we take off the universal, we take off the x, and we replace all the x's with whatever we want, and we can replace x with itself. If we do that, then we get if fx, then gy. We don't touch the y because it's a different variable. It's not attached to that for all x, and so this is a correct application. We have different variables in our conclusion, but that's okay because the for all x, when it comes off, only does anything to the x, and we actually just say let's leave the x alone, replace x with itself. We get if fx, then gy. And let's see. Let's look at 3005. For all x, gy, and we get gy. So what do you think? Do we think a rule applies here? Let's see if ui does. It does. Why? Well, because we take off for all x, the for all in x, we replace all occurrences of x with whatever we want. Well, there aren't any, and so we're just left with gi, and so that's it. There's nothing to replace. So those are just a few examples of UI. And let's get into our next video and see some UI actually applied in some derivations and the strategy for applying it.